We are pleased to present a federate data platform project that we have been working on the Museum of Art and History of Geneva, spanning from December 2023 to November 2024. The idea behind the project has been in development by several years, but it began to take concrete from in 2022 during discussion of the Department of Cultural and Digital Transition from the city of Geneva. It was here that the need for an interoperable platform was recognized with the goal of enabling interconnect access to data across various memory institutions in the city. In 2023, the Museum of Art and History launched a proof of concept initiative to assess the feasibility of the platform. The project was led by the museum's documentation and research center team, who worked primarily on this project during a year. The platform targeted a diverse audience, including academic research proficient in SPARQL, as well as enlightened amateurs. The Museum of Art and History of Geneva houses a collection of 650,000 objects covering fields such as archaeology, fine arts, applied arts, watchmaking, and graphic art. This diversity provides an excellent foundation for addressing the challenge of interoperability, as it allows the project to work with the museum objects, archives, and biographic resources. For data export and processing, we select only those works that have already been validated for online publication on the museum's collection website, entries that have been standardized and approved by the museum's conservators. In total, more than 100,000 records were exported from Museum Plus, the collection management software employed by the museum, and comprise information on artwork, comprising print, photographs, paintings, objects, person, historical event, as well as archaeological discovery, places, and exhibitions. We also exported and processed textual data. Specifically, we focus on Geneva, the institutional journal published from 1923 to 2017. Journals data include information about issues, articles, and authors. For archive data, we select the Lucien Florentin archive, consisting of articles by the Swiss journalist, art critic, and writer. As she worked and wrote about Geneva, it's what a particular interesting author to analyze, giving her attention to the local cultural milieu. The project unfolds in three phases. The first phase focuses on data normalization and reconciliation. The second on data modeling and transformation into linked open data. And the third on platform development and testing. In the following, we would like to reflect on some of the experience and challenge encountered during this project. Before curating the data, we'd like to stress the importance of a preliminary phase, the data analysis. The tailored report was produced to guide the curation process, ensuring our efforts were focused on prioritizing the fields we wanted to feature, making searchable and integrate as structured data on the platform, rather than expanding results on every field in the database. Taking place after the analysis, data curation was a cornerstone of this project, requiring extensive effort to normalize and reconcile diverse attributes from the museum's collection. This process involved curating over 19 different attributes, and it could be summarized in three types of actions, one subsequent to each other: data extraction, data normalization, record matching. The data extraction from the Museum Plus was performed using Groove programming language, and the data exported in CSV format to facilitate its use in OpenRefine, an open source tool for data cleaning and transformation. However, the process presents significant challenge, such as merging multiple data fields into a single column. For example, author's ID and role were combined within the same cell, necessitating further processing to ensure clarity and proper alignment, adding an extra layer of complexity to the workflow. The normalization process focuses on ensuring consistent expression and syntax, making data searchable, and eliminating duplicates. The main goal was to ensure great coherence and accuracy in the data, facilitating its handling and processing in subsequent stages. Dates were particularly challenging to standardize into ISO format, which required that to be expressed in consistent year, month, and day structure. For example, in this slide, we can see some of the different ways a century was expressed in the database. Record matching aims at integrating the platform data with external vocabularies and database. It's a key process for enriching the data by linking to its to recognize external vocabulary, enhancing internal information by reusing linked open data resources. For instance, the term in the denomination field associated with works were linked to the Art and Architecture Thesaurus, AAT. This ensured that users can easily retrieve resources across similar data sets. Authors were reconciled whenever possible with Wikidata and Getty ULA. The link allows us to retrieve and incorporate further information about the museum's author, such as biographical information, relate people or corporate bodies, and another heritage collection holding the author's works. Location data was aligned at the city level with Wikidata. The street of Geneva mentioned in the data, for example, the exhibition places, were aligned with data from Swiss Topo, the Swiss Federal Topographical Office. Using these two resources, we were able to retrieve coordinate, but also taxonomical geographical information and image. Normalization and reconciliation process were conducted simultaneously in Museum Plus and OpenRefine. This approach minimized the need for re-importing data into Museum Plus after the normalization, while utilizing OpenRefine's token and character-based algorithm to detect patterns and inconsistencies in the data. For reconciliation, much of the denomination data was manually aligned with AAT in Museum Plus. However, due to the limitation of the Museum Plus, example, the lack of integration with external database like Wikidata or Swiss Topo, this step and all the record matching operation were later completed externally in OpenRefine. Working simultaneously in both software represents one of the major challenges to the curation phase. In fact, the process of data extraction and reimportation was repeated several times, requiring significant coordination and management effort to prevent task duplication and maintain relational integrity between the documents. To focus not only on the metadata, but also in the content on the textual resources, we choose to process Geneva Journal and the Lucien Florentin archives with name entity recognition pipeline, identifying and categorizing entities like name, location, and dates within the text. As we will not have the time to train a specific model for this task, we choose to use a large language model, specifically ChatGPT 4.0 by OpenAI. By feeding the LLM an ad hoc prompt with the textual data in Alto XML, we asked to identify persons, place, institution, artworks, and exhibition. The results were formatted in a table using Python match with the internal record of the museum's database and saved in a separate field that was further mapped and transformed in RDF. The results obtained were satisfying but limited by the OCR quality of the original sources. A better authorization will greatly improve the results. The LLM had also the tendency, although minimal with respect of the overall dataset, to hallucinate some of the results. We have to be checked manually for consistency. Another important factor to consider is the financial cost of using such a solution may scale up quite fast, as the GPT API are particularly expensive. An open source alternative may be a better fit in this instance. Matching between LLM result and database records should also be improved, as they require time-consuming human control of the results. We transformed the curate data into a semantic information using the semantic reverse data modeling method. This protocol involves creating templates of semantic patterns that are applied across the dataset. The method follows an iterative process to identify the object of documentation, define their ontological scope, and determine the property needed to describe them. The result is a set of reusable semantic patterns for data transformation. We choose to develop the pattern using CDOC-CRM, as it's the de facto standard for cultural data, also because it was able to express the nuances of the data, but also because we have experience with it. We don't have time to delve into every single mapping created, but to summarize, we developed 10 different mappings covering artworks, person, place, event, archive, object, exhibition, and places. We use the mapping to give the transformation to RDF. For such a task, we use X3ML, Framework, and Engine Mapper. Other solutions are available for this task, starting from RML-based mappers such as YARML or MorphKG. The result of the process was a dataset in RDF composed by 5.5 million triplets, comprising 33 different classes and 47 distinct properties. Let's make an overview of the platform right now. The platform was developed in collaboration with the Advanced Service team using Research Space. Designed for cultural institutions, Research Space is an open source semantic platform for the management, visualization, and sharing of linked open data. Research Space sits on top of BlastGraph, a RDF database where we host the data. The platform gives the user the possibility to research and visualize data using 3 types of search: simple search, advanced search, and SparkQL search. The simple search allows users to find specific entities. Currently, we can retrieve resources based on their titles, author name, or denomination. By using the data bar, we can see the result divided by entity. On the side, various entity-dependent filters to help refine our search. We have options to display only a result with image, option to adjust the temporal range, and many others. For example, searching for Gustave Courbet allows us to access the record about the artist, which provides the list of metadata about him. By clicking on the Wikidata tab, we can access another constellation of information about the person. The metadata from Wikidata also include information about other institutions worldwide that hold works by Courbet. In addition, we have incorporated data from Union List of Artist Names from the Getty Institute, which provide information about different names, date of birth, etc. This demonstrates the result of our data reconciliation work, offering a more comprehensive and interconnected view of the artist's information across multiple sources. When searching for a specific work, such as Les Retours de la Mer by Félix Vallotton, user can view the object record as well as other key information such as iconography. By clicking on one of the iconography terms assigned to the work, for example, book, livre, we can automatically retrieve and see all the other artwork with books linked to it. Exhibition data is also accessible, showing which exhibition include this work. By clicking on the exhibition, we can navigate to its record and see other objects exhibited. Information related to the exhibition located is available as well. This allows us to explore related work or artists linked to one location. Additionally, we retrieve for each place using the Wikidata ID, its coordinate description, image, and other information as seen in the page. Back to the object page, user can consult archival items mention the object. We can access the scan of the articles in AAIF thanks to our collaboration with a data platform developed by the University of Geneva. The advanced search allows users to ask more complex predefined semantic questions. For example, they can find a woman born in Geneva between 1850 and 1900. The result of the advanced search can also be downloaded in a CSV. As you can see. The SparkQL search provides direct access to the SparkQL endpoint, enable users to query the database without the graphical interface. For instance, here is an example of SparkQL code to search for all objects representing Geneva created outside the city. The SparkQL endpoint also facilitates the CSV downloads, making it easy to generate visualization. For example, one could create a map showing the cities of origin for the Swiss artists in the museum's collection, or a chart visualizing the gender distribution of artists in the collection per kind of artwork. In conclusion, the museum has successfully demonstrated the feasibility of implementing a federated data platform. At the same time, we have also identified several challenges, both technical and social, that still need to be addressed. Data normalization is a key aspect of the data lifecycle, requiring either continuous effort or a method to limit the potential heterogeneity of the record. Both approaches, however, come with their own set of challenges. Furthermore, record matching at scale is complex and extremely time-consuming. Ideally, this process should occur during data insertion rather than after the fact, but the system must still provide the necessary tools to support this. Effective communication and coordination among team members with varying levels of experience regarding normalization practice is particularly challenging. We also realize how the imperative to datify and normalize information fundamentally transform our daily workflow, redefining the process of data entry and curation to better align with semantic systems. What's next? At this stage, we are still unsure when the platform will be open to the public. Before its launch, we aim to gather more feedback from both technical experts and potential users as to refine the platform and ensure the best possible experience. But the experience has been positive, so surely the work presented here will be at the core of a new federated research platform, which will include all the cultural institutions in the city of Geneva that we are currently developing. Thank you.